Okay, hello folks, welcome everyone. In this video, we are actually going to try to dive a bit deeper inside the contents of Open Metadata. So the idea is that we want to empower everyone in our community to be able and capable to understand how connectors work, as well as how to create new connectors. But first things first. Let's do a bit of recap on how Open Metadata works, what are a bit the fundamentals, and then bit by bit, we will keep jumping into the code and understanding what processes we need to follow here. Our main goal, the overall foundation and vision of the project, is in creating this centralized and shared metadata platform. And this can only happen if we are able to integrate metadata from multiple sources and make that metadata available and usable for different tools. To power all of this, we have a schema-first approach, where we are defining with JSON schema all of our entities, as well as the APIs, as well as the API operations. Then, if we take a brief look at the architecture, we will see that we have the Open Metadata Server, where we are serving the APIs that help us then connect to the UI, as well as to the ingestion framework. Okay, the ingestion framework is that Python project, this Open Metadata-ingestion module that is able to connect to multiple sources, be it Snowflake, Data Lake, BigQuery, MySQL, you name it, and translate the incoming metadata from these sources into the metadata standard that we have previously defined as JSON schemas, and then send that metadata into the Open Metadata Server. Then when we are talking about creating a connector, we are actually talking about understanding and using this ingestion framework. The first step into actually going into creating a connector is understanding how these connectors get deployed, how they work, how we are extracting the data, and also how we are sending that data back into the Open Metadata Server. And this happens with some Python classes that we call workflows. And not only that, we also need to take into consideration that as all operations between the client and server happen with an API, we also have a Python client available, this wrapper on the API that helps us streamline this communication. Then the workflow usually follows these three steps, or at least those are the three that we are interested at right now. The first one is the source. Okay, this is what we are going to develop now. And in this source is where we define the logic on where do I need to connect, how do I create this connection, and how I can start ingesting all of this data and sending that down to the other processes of the workflow. The second step, which might or might not be there, is the processor. Here, we might need to tune a bit, clean up, just change some specific shapes of the data that comes from the source. And once this process is done, we just get down into the sink. Okay, we are just explaining here this processor for completeness, but we are now just going to build a simple connector that will only be composed of the source and the sink. Then, let's start by building a connector. Let's start playing with some code. And in order to do that, the first step where everything starts in Open Metadata is via defining the JSON schemas. So we are not only using that to create the tables or the pipelines or the dashboards, we are also using the JSON schemas to define, for example, the connection classes. What are the attributes that I need to connect to a Redshift instance? Or what are the attributes that I need to connect to Snowflake? We want to have all of this information centralized in a single place, because then this is going to power up the ingestion framework as well as the UI. So once we start sharing data between components, the best place to actually put that is into something that is language agnostic and that allows us to then generate automatically all of this code. In Open Metadata, this gap, we fill it with the JSON schemas. So for the sake of the example, I'm just going to now build a simple connector that will be mimicking that I'm extracting metadata from MLflow. Okay, so MLflow is this machine learning centric experimentation platform where data scientists can run their experiments, can push the experiment metadata, can track their metrics, and so on and so forth. So I currently have MLflow running right now in my laptop, but this is also a connector that we have currently built in. So I'm just going to use it to explain how to create this JSON schema, and then we will keep following the steps on how we can actually work in the ingestion framework code to define these classes. That being said, now I just jumped into the Open Metadata repo. You can go on GitHub, create a fork, clone that fork into your laptop, and start working from main. Okay, let's not just work on past releases. Let's make sure that we are adding all of these contributions in our main branch. So here I'm showing the MLflow connection.json. Okay, this is the class, but sorry, this is the JSON file where we are actually defining all these properties that let us know, let the ingestion framework know, and let the UI know what specific elements I need to add in order to create a connection to MLflow. So you can find all of these files in the Open Metadata spec directory. And if you keep drilling down inside the resources is where we are defining all the JSON schemas powering the metadata standard. And inside services, connections, and ML model, we would find the MLflow connection. So first, let's take a look on what is going on here, and we will then start developing our new connector on top of that. So here we are putting the ID, what's the actual path of the connection JSON. We are giving a title. We are optionally giving a description. It's usually good practice to do that to try to help our readers what is going on, as well as the Java type, because we are saying that this JSON schema gets converted into code, right? It gets converted into Python code, it gets converted into Java code, and it gets converted into TypeScript code. So we can add these helpers, we can make sure that we are properly controlling in which package this connection object is going to be living in the Java code as well. Let's just not jump into the definitions yet, but let's take a look at the properties. Here in the properties is where we need to add all of these elements that help us create the connection. For example, for a database, here we would be putting the username, the password, the URL of the host, and whatnot, right? For MLflow, we just need to add the tracking URA and the registry URA. Basically, some strings such as localhost for where the MLflow is creating this tracking server, as well as, in this case, the database where I'm storing the experiments from MLflow. Then we also have some internal flags on what does this connector actually support. So all of them support the metadata extraction. Then we have some connectors into the databases that might support the profiler or not. So all of that are like some specific internal flags that help us enable or disable some of the characteristics directly in the UI that we internally use when serving all of this data. In this case, let's just focus on this tracking URI and this registry URI that are both required properties. Okay, this is important. Here is where we need to specify if something is really needed to create a connection, or maybe if this is just an extra parameter. For example, when creating a connection to a database service, I don't know, let's say MySQL, it's optional. for me to add a database, right? So the parameter database would not be present into these required fields. Then the type we have still to talk about. Okay, so this is kind of a small hack that we added to make sure that when this code gets transformed from the JSON schema into Python code, this transformation process between the JSON schema and Python is something that you can take a look at the docs on how to do so, and we're also going to see it now. So I'm just leaving that for later. But basically, this JSON schema is going to be converted into a Pydantic class. And we actually want to make sure that all of these Pydantic classes have different fields, have different types, so that we can automatically infer any Python dictionary, any JSON, any YAML to be automatically converted into a proper Pydantic file. So here we are kind of creating our own type, in this case, the annual flow type, to make sure that the signature of the class is also going to be different from connector to connector. In any case, this is just an internal detail, just trying to go through everything that we have here, but I, as an end user, as a contributor that I'm just interested into creating a new connector, I could do a process like this. Okay, so now I'm just going to cheat a little bit because I know that I want to create kind of this demo copy of the annual flow connector. So I'm just going to go on and copy this file, name it demo connection. Okay, so you can see that all of these JSONs have this convention of name of the source and then connection at the end. I'm just going to copy this. Yes, let's add that to Git. And I'm going to just change a few elements here. So we know that our connector is going to be named demo. So I'm just going to start updating all of these parameters here to make sure that there are no clashes. Let's change the type. It's important to change the type so that we are generating a new signature for the class. Then this needs to be propagated into the type in the properties. Let's add the right default. And then tracking URA and registry URA, we can just keep it like that. Okay, what is important is that we changed the ID, we changed the title, and the title is going to be used internally to create the Pydantic class. And it's also important that we change the file name, because the file name will be also the name of the Python module that it's going to be containing that class. However, making this change here, it's not everything that we need to do in terms of updating the JSON schemas. Because here we just created a connection. Okay, we put it in the right file, but we need to also update the ML model service JSON. These classes, these ML model service, dashboard service, database service, they control all of their possible connections that they can hold. So if we are talking about Redshift, Snowflake, and MySQL, the three of these things are database services, but the actual instantiation of their connection configuration can be different. I don't need the same parameters when I'm talking about Redshift or when I'm talking about Snowflake. So in these service classes is where we are defining these types with these enumerations to make sure that we have a complete control on all the types of connections that are supported in each specific service. In this case, I created my demo connection, so I'm just going to be adding that in the definitions as well. So this is demo, right? This is the type that I added here. Let's put the type in the ML model service type definitions, as well as in the ML model connection. So here we say, hey, I'm going to create a service that it's going to be of type whatever, in this case demo, and the connection object that this type demo is going to hold, it's referenced in a different JSON. In this case, it's the demo connection.json. So notice how JSON schema also allows not only to define new types, not only to create all of these structures, it also allows us to create links between connection objects and other entities. In this case, the ML model service. So just to recap, we created this demo connection file. This is just a copy paste of the ML flow just to have this example for you folks. We tuned a bit the types and the titles and the IDs to make sure that a new class is going to be generated when transforming this JSON schema into code. And we have added the right types and the right reference JSONs to make sure that now machine learning services know that they can be instantiated with different connections. And this is the first part of what we want to handle here. Then the second part is we can now start to build our source class. But before jumping into there, we need to generate the Python code, right? So to generate the Python code, now I'm in the directory where I have my OpenMetadata project cloned, just going to start and get inside my Python virtual environment. And we have everything already automated. So I can just run make generate. And this is going to run a great Python module, this code generation tool that will take all of the JSON schemas and transform them into Pydantic models. And this make generate call is also going to install the ingestion package locally. Now that I have that, I'm going to skip one of the steps. I know that this is a bit cheating, but I don't want it to take a lot of time here, which is that if we go into the architecture again, the ingestion framework is going to talk to the server. So if we create some new entities here, in this case, we are tuning out the ML model service entity. We're telling that it can be instantiated in a new way, that it can support a new connection. So this new shape, these new classes that I'm supporting in the ingestion framework, they also need to be supported in the server. So I do not only need to create these Python classes, these Pydantic classes, just for me to play around and get done with it. I also will need to rebuild the server so that when we are pushing the ML service data into the server, it's going to be able to recognize these new connections. To do so, you can actually run sh docker run local docker.sh. All of this is in the documentation, so don't worry about that. And this file, what it's going to do is automatically run the Maven project, prepare the data files in the distribution, restart all of the Docker containers locally for you. So that's kind of our daily tool to start developing with OpenMetadata. That being said, now I am into the Python project, and the first thing that I want to show you is that I can now look for this demo connection, and you see that this Python class was just generated into my generated module. So I have the ingesting module, and inside my sources, there's this generated directory. This is what automatically happens when we run the make generate command. So here you can see how this demo connection class was created with this other class kind of helping us hack the signature to allow this automatic inference from dictionaries, JSONs, YAMLs, whatever, into Pydantic models, as well as telling us that the tracking URI and the registry URI are required fields. That's why we see the ellipses here. Okay, so this is something that you folks might need to validate. You are starting, you created your JSON schemas. Let's make sure that your classes have actually been properly generated from these JSON schemas. Otherwise, you're going to have a hard time actually trying to move all the pieces around into the ingestion framework code. Now, before we continue, I'd like to just jump back for a bit on a more theoretical side, just for you to understand how the source classes and the workflow interact with them. So we said that the workflow is the actual pipeline that knows how to extract the data from the source, transform that data into open metadata classes, into these open metadata standards, and then send those as payloads to the API. Now, this process is already there. Okay, the workflow, this is a class that already exists. So we don't really need to do anything on top of that, because this is templated, this is automated, right? We're not reinventing the wheel every time that we create a new source. So now we are just going to focus on how to develop this source. But here, one of the struggles that we had at the beginning is, okay, how can I just eliminate some of the boilerplate here when I'm creating a new source? And also to answer a super important question, which is, what pieces of metadata can I extract for each of the sources? So at the beginning, we had actually a hard time maintaining and saying, okay, from this source, I'm going to extract lineage and tags. From this other source, we maybe forget to develop the lineage, or maybe the implementation is not trivial. So at that point, we just omit that. But then we don't know what it's missing. We don't know what's actually our metadata coverage from the different sources. And we were kind of redeveloping the same functionalities on and on and on. And actually, to just get this problem out of the way, we created something that we called topology. Okay, so the topology is what it helps us translate the structure that each service has into specific functions that we just need to write to get our source connection definition done. This means that after I explain this part, we will jump into creating our source class, and you will see that actually we have everything is scaffolded. We just need to add some specific contents into specific functions, and then the whole process of the connection and how to extract the metadata, how to send the metadata, right? All of this internal flow will already be there. That before jumping that, I think that it's important that we just spend a couple of minutes in understanding how this topology works and why this is there. So the main reason that we actually added that was that the hierarchies between different services are different, and the metadata that we want to extract from different services is different. For example, in this case, if we talk about a pipeline service, we know that the fully qualified name will be the service name dot the pipeline. So we basically need to extract two main entities, the pipeline service and the pipeline itself. Then we define this extraction process into what we call nodes. Okay, so these nodes, they help us kind of maintain this hierarchy of what are the requirements that I need when I jump from step to step. To create a service, I have no requirement. Services can exist by themselves. But the time that I want to create a pipeline needs to live inside the service. So I can only jump into the pipeline node once the service node has been properly run and properly ingested into open metadata. And we do not only define kind of this vertical hierarchy, like which steps do I need to follow first, which nodes do I need to actually define. We have also added the concept of stages, kind of which types of metadata I can feed, in this case, to an existing pipeline. So for me, the different stages to completely ingest all the metadata related to a pipeline are, first of all, I need to get my pipeline. Once I have my pipeline, I can send some status data about that pipeline. And once I have this status data, I can pick up the lineage. So the process would be the workflow starts, the source class gets instantiated, then we get into the get service node, and this get service node only has a single stage, which is delivering the service to the sink. Then we run the node that is actually in charge of getting the pipeline information. And for us to get all the information from the pipeline, we need to first ingest the pipeline, then ingest the status of the pipeline, and finally ingest the lineage of the pipeline. We now take an example that is a bit more elaborate. That would be, for example, for tables, because the FQN, the hierarchy of a table, is quite different. We have the service, then we have the database, the schema, and finally we have the table. So I have 4 different nodes, and each of these nodes is going to have a specific stages that need to run. In this case, for the service, just need 1 stage. Let's get the service, let's send that. For the database, it's the same. I'm creating the database, reusing the information that I know about the service, because again, a database can only exist within a service. Same happens with the schema. Schema can only exist within a database. So the only point in time that I can process a schema is after I process the database that contains such a schema. And finally, we get to the table. And here it's where we're going to send the data about the table, about the DBT model, about lineage, etc., etc., etc. If we just try to generalize this process a bit, and we will see that now into the Python code, we'll see that each node is going to contain all of these stages. And internally, what happens is that the node is just going to be a function. And this function is going to return us some arguments, some objects. And these objects are going to be sent every time to the different stages. So we run the node function. This node function keeps returning us some objects. Then these objects get sent first to the stage 1. And then once the stage 1 has been properly processed, we're going to keep following and send the same object as an input parameter, as an argument for the second stage, and so on and so forth. What happens then within this stage is that we are yielding the entity. The stage is the function that knows how to, based on the parameters from the node, get the metadata from the source and translate that into open metadata entities. Then these open metadata entities will just be yielded down to the workflow, because we know that the workflow has this first step that is the source, and then the source gets finally connected into the sink. So what happens within a stage is that we are yielding the entity. The stage is the function that knows how to translate the metadata from the sources into the metadata standard. And this element will be passed down to the workflow until it reaches the sink, and once at the sink, it will get back into the Open Metadata API. And also what is interesting to notice is that once we have processed each of the elements that get yielded in every stage, we are caching that. So the source has a complete hierarchical view of in which step we are. This means that while I'm here processing this table in this specific function, in this specific step, I can obtain the necessary information about what is my schema, what is my database, and what is my service. Because this information is a hierarchy that I need. It's information that I actually need to pass into the table to properly instantiate that table entity. So now that we have this present, let's take a look, for example, at this pipeline service. So all of these classes are already defined. So this is nothing that you would need to do on top of here. This is just, I made a typo. This is just for you to understand a bit better what are the required ingredients when we are actually talking about creating a source. So in this case, we've seen that the pipeline has 2 nodes, the root node and then the pipeline node. The root node will have this producer, this function that will be called get services that will bring us an input argument that will be sent to each of the stages. In this case, I just have a single stage that will be run in this function, this yield create request pipeline service function that will yield entities of type pipeline service. And the children of this specific node, it's the pipeline node that I can find just down here. And then the logic is the same. I will have a function called getPipeline that will produce some objects, and these objects will be passed as input arguments for each of the stages. The resulting element for this function will be automatically sent to this other function called yieldPipeline, will be also sent to this function called yieldPipelineStatus once the previous stage has been completed, and so on and so forth. So the important thing here is for you to just understand a bit the structure of this topology and to know how to read and how to actually understand which are the pieces of information that you need to define. So this structure is here in the pipeline service topology, and this is what it's going to be passed into the pipeline service source. This means that any pipeline source will extend this class, and this class will already know all the ingredients that are defined, because these ingredients are based on the pipeline service topology. So basically, by creating this dynamic definition and creating this class inheritance, we have a super clear guide of which are the functions that I need to define to create a connector. Now, stop talking about pipelines, and I will just jump into the ML model, okay? Because that's actually what we are here to define. So I'm just going to show real quick what is the topology of an ML model service. And as you can see, this is super simple. I just have two nodes, and each of the nodes just have a single stage. As always, we will start by getting our service, and once we have our service, we will keep building our ML models. We will keep building this entity of type ML model that will be passed to the sink via the workflow, and then the sink will put that information into the OpenMetadata server, automatically creating these entities for us. But as we said, this ML model service topology, this is just a definition. The actual class that we need to extend is this one, the ML model service source. So here we just have kind of some dynamic scaffolding on really just picking up all of the information that we need. But let's just take a look at how these classes are initialized, and later on we will jump on all of these functions. But the first step here is to understanding what is happening in the init. So we are creating our OpenMetadata object, this OpenMetadata client that helps us talk with the API in case we ever need that. We are creating the source configuration. In this case, this is an ML model, so this will be an ML model service metadata pipeline. But what is interesting is that here is where we are actually going to get the connection to our source system. Okay, and this source system is going to be automatically picked up from the service connection. The service connection is the class that ultimately defines this demo connection in this case. So what we actually need to do is to implement the get connection and the test connection functions for our demo connection class. So if I jump into the get connection, we see that we are just running a single dispatch, right? This means that we have a single function that dynamically, depending on the type of the first input argument, it's just going to call an internal implementation on another. In this case, we know that we are talking about adapting something for MLflow. So again, I'm just going to cheat a little bit and copy and paste this function here. But instead of talking of an MLflow connection, just going to talk about this demo connection that I need to import from my metadata generated module. Now, this is kind of a utility that we internally use, so we don't really want to force, like at any import of any module, the import of all of these clients, right? We want to keep the ingestion framework as lightweight as possible. We don't want to force the installation of all of these packages. So we usually wrap the actual clients. So in this case, I know that I can use this MLflow package to import the client to interact with MLflow directly, but I don't want to do that kind of out of the box. I don't want to force that import. So we are importing directly within the function, and we are also wrapping up these classes. So this client, it's not going to be flying solo, it's going to be wrapped in some client. In this case, we also need to define our own, which I'm going to copy paste as well. I'm just going to call it demo client. Okay, this is important to just keep creating new wrappers, because when I jump into the connection and I use this new wrapper here for the test connection, just need to make sure that I'm going to call a different implementation. Just going to import this client here, and the actual implementation of testing a connection is just going to be the same. Now that we have the connection sorted, let's keep checking what else do I need to do here. So we see that in the ML model service source, the get services method and the yield create request ML model service, this super not verbose function, they are already defined. And this function is actually like defined here in my topology. So this means that I don't need to care about this part. How we obtain the data from the services and how we send the data from the services down in the workflow, this is something that we have already done for all of our connectors. So we can just really not think about that, and we can just focus on getting the right ML models and yielding the right ML models. We just jump back into our service source. We can see that now is where the help starts, because I have some abstract methods that are already telling me that, hey, if you want to create a connector, you need to take a look at all of these implementations. And all of these implementations, they do not only tell me that, hey, you need to create the node function that will be returning as this iterable of whatever object that will be passed as a parameter into the yield ML model. We are also giving sometimes some helpers, in this case for saying, hey, we know that a properly informed ML model needs to have some hyperparameters, needs to have some ML store, some features, some algorithm information. So all of these functions are already here as abstract methods for us to know, now that we are going to create our new source class based on this service, Python itself is going to tell us, hey, you just need to make sure that you are covering these 6 functions. If you are giving me these 6 functions, all the rest of the process will automatically happen for you. So that being said, I'm going to create a Python file here, going to call it demo.py, and the name is actually important, okay? So our type is called demo, right? The type of our connector. So we need to make sure that this type becomes the module name, because once we are creating the workflow and everything, we have some dynamic instantiation of the sources, and we try to create this import on the fly. So let's make sure that we are properly following this convention here. Now that I'm in this type, let me actually split this, and I will just close that for a second so that I can develop a bit more comfortably. So I'm just going to create this class, demo source, that it's going to extend this element here that I need to import, right? And now something needs to happen. And now we want to start implementing this demo source. And Python, in this case, PyCharm, is already helping me and telling me that demo source must implement all abstract methods. So I'm just going to get this out of the way, and it's telling me that I need to implement all of this, right? How to create the class, this comes from the source, and all of these methods that are defined in my ML model service source. Let's click OK. And I have almost all of the signatures, all of the information that I need to start hacking around. I'm actually going to move the create at the top because I kind of like it a bit more. And I'm also going to add some doc strings here. So please add doc strings if you're going to open a PR, just make sure that we are following best practices on linting and so on. So I'm just going to put some nonsense. This is a demo source that gets some dummy data. And in order to implement this create method, what the most comfortable way in this case would just to pick up any other existing connector. I just usually go with MySQL, and I will just do some copy paste of this create, and I will explain what we are doing here. And to get the import correctly, I need this. So here, this is just a small rename that we do just to not mix what is the actual source implementation between the source required by the workflow. We just do this small rename. Just going to import that here as well. And this create method, it's actually what it's going to instantiate this demo source. And here, I'm not talking about the MySQL connection. I'm talking about the demo connection. That's the demo, that's the connection they want to create for this source. So here, we will get past a dictionary. This dictionary will be dynamically generating this workflow source. We are going to pick up the connection from this source and actually validating that we are properly getting a demo connection. And let's import this exception as well. So now we got the create out of the way, and we just need to make sure that we are implementing the functions here that we want. In this case, I'm just going to keep it simple. So I'm not really going to do all of these connections for the real MLflow instance. I'm just going to create just a dummy class holding the data just to play a bit with that. So I'm just going to create some demo model. It's going to be a Pydantic model with a name. So each model will have a name, and I'll go reader, which is also going to be string. Then we know that we need to implement first these get ML models. This will be the function that it's going to start the node, and that will anything that gets returned from this function will be passed through these stages. So in this case, this function is just going to return some demo models. It won't have any specific parameter. We can just kill that out. Say yield, demo model, name, my first model, and algorithm. This is just going to be GPT-3 because it's pretty cool. And then we're going to yield our demo model, name, second model, and algorithm, just random neural network. I don't have imagination today. And then we know that the getML models is returning some demo model. So this will be the input parameter for my yield ML model, because this is the function on this stage. So I will just come here, say that this is going to receive a model that will be a demo model, but that will indeed return a create ML model request. So this signature here I need to keep. So I will yield this create ML model request. And now let's take a look at actually what ingredients I need to add when feeding the required information here. So I need a name that is required, and I need the algorithm that is required, and I need a service that's also required. Okay, so where do I have that? Here. So if we now take a look at how we were doing that, for example, for MLflow, we see that in the yield ML model, we're basically just picking up some information from all of this function that the service helps us with this abstract method decorator and says, hey, you might need to actually implement that. So for now, I'm just going to copy these contents, and I'm just going to clean out whatever I don't need. Just copying it here. We know that the description is not necessary, so I'm just going to kill that out. The algorithm I actually need, so for now, I'm going to keep that. Parameters not needed, features not needed, ML store as well, but I do need this service. So this part I'm just going to keep. And as you can see, we are using this context, we are using this cache. So when the topology runs, we are first getting the service information gets cached into this context, and then we are able to pick up the service that was just generated in previous steps directly from our source. So we are creating now this reference, this pointer to another entity that has been created just from the context, saying that in my source, I go into the context, I'm interested in this ML model service, and I'm just going to pick up the ID. Then, for those of you asking how I'm actually able to know if this is the right path, if we just now take a quick look into the topology definition, look, here in the stage, we defined the context. So this is going to be the key of the context, like the key of the attribute, the name of the attribute that will be stored in the context and will be of this type. So basically, I know that I just need to go to my context, pick up this attribute, and pick up the ID, because the type ML model source, which is, sorry, I got lost, which is here, this actual type, I know that has some IDs. So this is already working for me. And to just spice things up, I can say that the algorithm will also be picking up some model information, right? To not make everything so linear. So I'm just going to put this here as an input parameter, and I'm just going to make sure that this returns the model.algorithm, and then this function gets code here with the model. And all of this, I can just keep it here, right? I keep it here, they are not implemented. And this will also help me when I come back and I revisit this source to see that, okay, there are some functions, I know that there is some information that I might be missing. I might need to come back in the future and actually add all of these missing pieces. Okay, so now we have all the ingredients ready, and we should be able to start running our connector. We will use directly the metadata CLI. Let's not jump into the UI yet. Let's just make sure that all the ingredients are working. But before doing that, I actually noticed that when preparing the connections, I messed it up a little bit, right? So I actually just updated this type here instead of properly creating this new function, registering with the new type. So now I just went ahead and got that fixed. And another thing that I got ready here is this demo.yaml file. Okay, so this is the workflow file that we can use to actually execute the metadata ingestion. So with this file, we are defining this whole workflow. We are defining what is our source. In this case, we are using something of type demo that has this specific config. And notice how these parameters are the ones that we defined in the JSON schema. And we're also putting the sync. In this case, the sync, just for simplicity, we are going into open metadata. That's what we are doing in 99% of the cases. And here we are just adding the connection to the server and passing open metadata as the auth provider. Okay, I'm working with a main branch that's after 0.11.1. So we are delivering open metadata out of the box with the basic auth. So you would need to actually use this JWT token. And this lower level, I think that they can just kill it for now. There's not that any more verbosity. And one last step that we need to double check here is in terms of libraries. Okay, in this case, I don't need to really add anything because I'm just building something on top of MLflow, right? But if we take a look here at the setup.python file, so we have all the libraries that should be installed for the different connectors. You can find this information in the plugins dictionary. So in this case, let's imagine that I will need to install something for my demo connector. I would just go ahead and say demo and whatever I need, right? Maybe let's actually look for MLflow and just to have the full example. So I'm just going to add here the required libraries from MLflow, and I'm just going to jump into the terminal. And in this case, instead of a make install, I will need to do a pip install locally of my ingestion directory with the demo plugin. Just going to run that real quick. So that got installed. And now I can just run my workflow. So I have this demo.yaml file that I just showed. And let's execute that from the CLI with the ingest and see how the workflow just ran. And we see this local demo. This is the name that we put in the service with first model, and local demo with the second model. So now I can just jump into my open metadata UI, enter, put my credentials, and if I take a look at my ML models, I see that I have already my first model, I have my second model. I can also get into the same page just by taking a look at the ML model services. Now, that's actually the attribute, sorry, here is where we can find the services. I see my local demo with my registry, my tracking, all the information that I just passed with the names. So you can see no tiers, no anything, because we just put the algorithm information. And that would be it. So to recap the steps, we took a look at the JSON schemas, how to generate those files, how to create the code from those files. And then basically we were just reviewing what functions the topology and the service classes are helping me to implement. In this case, I know that it's an ML service, so I can just inherit from the ML service class, take a look at what methods are marked as an abstract method, and just bit by bit, keep implementing our things, keep making sure that we are getting the right data from the sources. We kind of just played this part out. We just created some mock data, but in those functions is where you would put the logic to actually get whatever you need from the services. And as you can see, you can just test it out with the CLI real quick. You will have all of the feedback already there in the UI. And hopefully this was useful. Enjoy hacking.